Hi everyone, this video will be for the annuities and specifically the level annuities. What do you mean by level annuity? It is a series of equal payments made at regular intervals. So we have equal payments and the period time are the same. So we will see two types of this level annuity. We will see the ordinary annuity where the payments are made at the end of each period, and the annuity due where the payments are made at the beginning of each period. So let's start with the future value of ordinary annuities. Now, suppose that you deposit $100 at the end of each year for 3 years. How to get the future value of all those payments? We have 3 payments here. So how to get the future value of all those payments? So let's start with the future value of this payment. So it is we know that future value is present value times 1 plus the interest power the number of period. Here the number of periods from the third period to the third period is 0. So here the future value of this one is 100 times 1 plus the interest power 0, which is the same as 100. So let's calculate it. So future value, actually the future value of all those payments is the sum of the future value of this one plus this one plus this one. We said this one is 100 times 1 plus the interest power 0. For this one it is actually we need to take it to the future by one period, so it is 100 times 1 plus the interest power 1, and finally for the last one we need to take it for 2 periods, so it is 100 times 1 plus the interest power 2. We can get 100 as the common factor for this, so we can write it 100 times 1 plus the interest power 0 and so on. Here, as you can see, it is actually a geometric series, and the sum of a geometric series is actually the first, this is the formula, the first term times 1 minus r, which is r is the ratio, and for our case here it is 1 plus the interest power n, which is the number of term, and here the number of term is n, which is the number of periods, 1, 2 and 3. Here it is 3, which is the same as the number of periods. So let's apply this here, and we will get so the first term is this one, so 1 plus anything or 1 power anything is 1, so the first term is 1 here. Then 1 minus the ratio, which is ratio, we said it is 1 plus the interest, 1 plus the interest power 3, which is the number of periods, divided by 1 minus actually here it is plus 1 minus 1 plus the interest. I will correct it. Okay, so it is a plus here, and then we have 1 minus 1 plus the interest power 3 divided by minus 1, because 1 minus 1 is 0, then it remains here minus the interest, and we can multiply this by minus 1, so we get the by minus 1, sorry, here minus, we multiply by minus 1, this one we multiply it by minus 1 divided by minus 1, and we get this. So in the end we can write the formula for ordinary annuities, the future value of ordinary annuities, like this. So it is 1 plus the interest power 1 here, 1 plus the interest power n, minus 1 divided by the interest, and don't forget that we have this 100 here, so times the p here. So the future value of ordinary annuity is the payment times 1 plus the interest power n minus 1 over n. Now let's see how it works with annuity due. When we have an annuity due, it means the payment is made at the beginning of each year. So here the first payment is made here at the first period, the second payment here, the third here. So we need to take them all to the future. For this one it will be for one period, for this one it will be for two periods, so it is 100 times 1 plus the interest power 2, and the last one will be for 3 periods. We get this, and we can write it like this: 100 times as a common factor times 1 plus the interest power 1, and so on. Here also we have a sequence, like a geometric sequence, a geometric series, with first term as 1 plus the interest. So we can write it like this. So it will be, this is the first term, times 1 minus 1 plus the interest power 3 over 1 minus 1 plus the interest. Here also again it is plus the interest. So it equals 1 plus the interest, same thing, times 1 minus 1 plus the interest power 3 divided by minus 1. We multiply it by minus 1 over minus 1, then in the end we get this. So for the future value due is this times this 100. So 100 represents the P. So we can write the formula like this. So the future value of due annuity, or annuity due, is P times 1 plus the interest times 1 plus the interest power n minus 1 over the interest. As you can see, P times this is actually the future value of ordinary annuities. So we can write future value due as the future value ordinary times 1 plus the interest, which means it is the same but compounded for one additional period. So now let's see with an example. Imagine you deposit $1,000 at the end of each year for 5 years into an account that pays 5% per year. So how to find the future value of this ordinary annuity? It is ordinary because it is made at the end of each year. So we apply our formula, which says the future value of ordinary annuity equals the P, which is payment, times 1 plus the interest power n number of periods minus 1 divided by the interest. So we replace with numbers and we get in the end this amount. So this is the future value of all those payments. Now imagine that payment is made at the beginning, not at the end. So we apply the formula of future value of due, or the annuity due, that says it is the future value of ordinary times 1 plus the interest, as we said, compounded for one additional unit. So it is the future value here with the result we got here times 1 plus the interest, which is 0.05, and that is the future value due. Now let's see if in case we have different compounding periods. So let's say it is monthly and not yearly. Now, so if you deposit $100 at the end of each month for 5 years into an account that pays 5% per year, so the formula we use here is the same as we did with the yearly payment, but here we need first to find the number of periods in months, and also the interest we use here is monthly interest rate. So how to find the monthly, how to find the n, which is the number of months? It's easy. So first thing, the n, which is the number of months, is m times t. M is the number of period of compounding per year times the number of years, which is 5 times 12, which is 60 months. For the interest rate, we can directly, monthly interest rate, we can divide directly the nominal interest rate divided by the number of periods, which is 12, and we got the monthly interest rate. We apply our formula directly using the new monthly interest rate, using n as the number of periods, which is 60, and this is the annual, actually the future value of this ordinary annuity monthly payment. Now imagine this interest rate is not nominal but effective. So how to find the monthly rate from effective interest rate? It's easy as well. So you can convert this annual to monthly by using this formula. It is the effective plus 1 power 1 over m minus 1, and we get this monthly rate from this effective. Then we apply it in our formula. Future value is the payment, which is 100 times 1 plus the interest power n number of months divided by the interest. Here we have minus 1 divided by the interest, and this is the future value of this ordinary annuities. If we want to find the future value of annuity due, it is actually the same as this, but you need to take it to the future further for one additional period. So we just multiply this by 1 plus the interest, and you get the future value of a due or annuity due. Thank you for watching, and see you in the next video for the present value of annuities.